Today we're gonna solve the week 13, I think, yeah. Physics quiz. Let's start. 0.8 kilowatt washing machine works on 220 volts and 3.6 amperes. Which of the following fuses is most suitable? So you're gonna look at the 3.6 and you're gonna pick the closest thing bigger than it. Because you always look at the amperes. If they didn't give us the amperes, you calculate it by dividing the kilowatts. First you transform it to watts, then you divide it by 220. You're gonna get this number either way. They just gave it to you, so it's 4 amperes. Here, when you have a path of waves and they're gonna hit a flat barrier, they're gonna go almost perpendicular to the barrier, and the waves are gonna be always perpendicular to this line. Always. Now, moving on. Here we have a ripple tank and it's set to hold two regions of water, deep and shallow. The oscillator will create a wave. Now, when this wave, the frequency and the period will never change, no matter what happens to the wave. Now, the wavelength of the deep water is more than the shallow water. So when you're going from deep to less deep, the wavelength will decrease. So from deep to shallow, the wavelength and speed will decrease. And that's what happens. And that is it. Moving on. Okay, yeah, when you have a ripple tank and when you have straight waves going through a tiny slit, they will diffract and become circular like this almost. Moving on. Okay, so how long does it take for the Earth to orbit around the Sun, which means how long is a year? And it's 365.26 days. Now, in the southern hemisphere in position A, this is the southern hemisphere. Yeah. Now, we can tell that this part, the northern hemisphere, is more pointed towards the Sun, where this one is pushed away. Since the northern hemisphere is pointed towards the Sun, it's summer in the northern hemisphere, whereas it is winter in the southern hemisphere. And if Earth's axis of rotation was perpendicular to the orbital plane, how would the time of sunlight exposure on Earth be different? So we know that the axis is tilted at an angle of 23 point something. I forgot the something. And let's say it was perpendicular. Then each part of the Earth would get exactly 12 hours. Now, what most likely is the month in position B? Let's see. In position B, if how I like to remember it is that we're in the northern hemisphere. Now, we're in the northern hemisphere, so in this we can tell from the picture that here the southern hemisphere is pointed towards the Earth. So if it's pointed towards the Earth, it is summer in the southern hemisphere. So if it's summer in the southern hemisphere, then it must be winter in the northern hemisphere, which is where we are. And we get our winters in December. Moving on. Which statement is true about water waves incident at a straight barrier? So when you have a straight wave and it arrives to a straight barrier, it's gonna reflect, and it follows it obeys. Here it says do not. It does obey the laws of reflection. They're represented by rays that are perpendicular, like we saw in a few questions ago. The angle of incidence is equal to the angle of reflection. This is true because we said it obeys the laws of reflection. Moving on. When we have a circular wave, like waves that go like this, and they bump into a straight barrier, it's gonna reflect. So it undergoes reflection. Now, when it reflects, it's gonna look like it's coming like this. So it's gonna look like it's coming from another object that's here. It seems to come from a point behind the barrier. And of course, like always, the laws of reflection are obeyed. It will not refract, and the laws are obeyed. Here, this is wrong because it says they're not. Moving on. Okay, when you have the waves moving through a small slit, If you don't understand this, watch the video I made last time the question came. I showed it on a simulator. It will bend like this. Moving on. If it's two slits, it will be that one. Yeah, this one. Yeah. So the factor that affects the amount of diffraction would be the width of the gap and the wavelength of the water waves, not the density of the water, nor the types of stones, nor the amplitude. Moving on. Okay, so this wave, it's a water wave that's circular, so it's mechanical because they're moving each other, they're waves. The water can be classified as transverse because the displacement is perpendicular. This is obvious. See, it's heard. Now the wavelength is, they told us each square is 20 centimeters. So we need to count the squares. There's 1 square, 2 square, 3 square, 4 square. Since there's 4 squares, 4 times 20 centimeters equals 80 centimeters. They want it in meters, so it is 0.8 meters. That is it. Now they want the speed of the wave. We know that this is the picture taken after 2.6 seconds. So you have to count, this is how many blocks away. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It's 16 blocks away. Now 16 times 20, which is how many each block is, it is 320 centimeters, which is the same as 3.2 meters. Since it's 3.2 meters away, that's how many meters we have in 2.6 seconds. And we know speed is meter over time, 2.6. Let me do it really quickly on my calculator. 3.2 divided by 2.6 gives us 1.2. And that is it. 1.2 meters per second. Now the frequency of the wave, we know that velocity equals lambda f. Velocity is the speed, which is 1.2 equals lambda, which is the wavelength, 0.8 times frequency. So 1.2 divided by 0.8 will give us 1.5. And that is it for this question. Let us move on. Okay, now we have this question. The diagram below represents the crests of the wave spreading through the medium. The smallest graduation represents 10 centimeters and the wave propagates from S to A in 4 seconds. Now, if it goes from being a point or like a dark point to A in 4 seconds, they're asking us when does it become a trough. Now we know when we have a dark line, it's a crest, not a trough. So if it takes 4 seconds to get a crest, if it takes 4 seconds to move from a crest to a crest, then the time it takes to move from a crest to a trough is half of that. So it is 2 seconds. As the crest A becomes a trough, then a crest again, it will propagate by another. Now, let's look at the graph again. It will propagate by another. So, another, we have to count the blocks. So you have here 1 block, 2 block, 3 block, 4 block, 5 block, 6 blocks away from A, which means it is 6 times 10, 60 centimeters. Now let's see, 2 seconds and 60 centimeters. Moving on. Okay, so in order to locate their prey, a bat sends out a sound wave. When the sound wave hits an object, it bounces off the object and returns to the bat's ear. A bat listens through echo produced and the figures where it intersects it, how big it is. A bat can emit the sounds from 12 kilohertz to 160 kilohertz, and the speed of sound in air is 340 meters per second. What is the sound with the longest wavelength that the bat can produce is, now we know the formula, it's velocity equals frequency times wavelength. Now, if you want the longest wavelength, we know that frequency and wavelength are inversely proportional. So to get the longest wavelength, you have to use the smallest frequency. So we will do 340 equals 1200 because it's 12 kilohertz equals lambda, Or if you don't want to do it because they want it in millimeters, you're going to end up by dividing by 100. So 340 equals 12 times lambda, and then you're going to get your answer in millimeters. 340 divided by 12, lambda equals 28.3. They want it to the nearest integer, so only 28. The bat hears the echo 0.05 seconds after it screeches. The insect that sound waves bounces off of it to 1 decimal place is... Now, we know that speed equals the distance over time. And we know here the distance is the sound from the bat's mouth to the insect and back. So, if the bat hears the echo 0.05 seconds after it screeches, so time is 0.05. The speed we know is 340. 0.05 times 340, D will equal to 17. You're gonna say, okay, let's put 17, but no. We said the distance here is the sound from the bat and back. So it is 2 times the distance away. So here it's really 2D because you need the sound to go and come back. So 2D, 17 divided by 2 is 8.5. Let's move on. Okay, so this, genuinely, I think you actually have to memorize it from the what's it called, the book. Which part of the spectrum is 120 nanometers, or memorize it. Ultraviolet radiation is 120 nanometers in vacuum. Now the frequency, we know that the frequency is equal to 1 over lambda. So 1 over 120 times 10 power negative 9. Wait. My bad, guys. I used the wrong formula. Anyways, the actual formula we needed to use is velocity equals frequency times lambda, which is the wavelength. Now, the velocity here, we're talking about light. Electromagnetic means light. So it is the speed of light, which is 3 times 10 power 8. Lambda is 120 times 10 power negative 9. 3 times 10 power 8 divided by this will give you 2.5 times 10 to the power of 15 hertz. And that is your answer. That's it for this quiz. Hope you understood everything. Have a good day. Bye.